All right, everyone. So I'm just going to take a look at maybe some notations and clarify things. If we start off with y is equal to f of x, and f of x is our parent function, and we're going to transform it to y is equal to a f bx. Now, a is just really, we're multiplying our function by this value, and b is really multiplying the domain of our input going in. But it's really important to delineate what is A and what is B here. So if I were to look at our first example, given the function or the graph of y is equal to f of x, we're going to denote the domain and range. And the domain is going to be -2 to 4, and my range is 0 to 3. So we're going to sketch the graphs of the following transform graphs, write out the mapping notation, and describe in words the transformations. So g of x is our new function that we wish to transform. When I take a look, I see that a is equal to 2. So I start off with point xy. And when a is equal to 2, we're going to stretch our points, the y value, by a factor of 2. And really, we're multiplying the y values by 2. Now, describe in words what this is called. Well, this would be called a vertical stretch by a factor of 2. Note the domain and range of our transformed functions. Well, I guess I need to transform this function. So I'm going to start off with this point right here. So -2, 3 turns into -2, 6. I'm multiplying my y value by 2. 0, 0 changes in no way. Well, we multiply our y value by 2. That is 0 times 2 is 0. 2, 1 turns into 2, 2. 4, 1 becomes 4, 2. So this is my newly transformed function. How is the domain and range affected? Well, you can almost answer it by just looking at the mapping notation. My domain remains the same. I have done nothing to the x values, but my range is changed insofar as both my x and y, or both my y value, or both the endpoints of my domain were multiplied by 2. All right. So this next one, D, if h of x is equal to 1/2 f of x. All right. So a is 1/2. And my mapping notation says I start off with point xy, and really I move to point x, comma, 1/2 y. It's really the same question as before, except now there's a fraction involved I need to multiply by a half. Now, I'm just going to erase all of this, if you don't mind. And I'm just going to rewrite D as a separate graph. So if I take point -2, 3, I have to multiply the y value by a half. And that turns into -2, 3/2. 0, 0 changes to 0.00. 2, 1, well, remember, I'm just multiplying my y value by a half, becomes 2, 1/2. 4, 1 becomes 4, 1/2. And now what we see is this. Now, it's almost like we squished this down, didn't it? So this transformation is, we could call this, and this won't make sense, but technically it's okay. Stretched, sorry, missing a word. vertically stretched by a factor of 1/2, call it. So we could also say this compressed, and this means the same thing. Compressed by a factor of 2. And to me, this is where the words actually match what we're doing. We're compressing the graph. However, both are correct. And typically, I encourage the students to focus on the first one before they attempt number 2. How does the domain and range change? Well, surprise, the domain stays the same. We did nothing to the individual x values, but the range is changed because now we simply multiply each of our y values by 1/2.